So I am here in the beautiful city of Atlanta, where frequently the power may go off, but it's all good. We make it all work. And I am also the director of the Atlanta University Center Data Science Initiative. So I really enjoy all things data. I'm really excited about our panel and our session today. So as our speakers are presenting, I'm hoping in the background that you will look them up on LinkedIn and connect with them, and maybe even drop your LinkedIn in the chat so we can all be connected. And just think of some questions to ask them. If you're like me and you can't remember, I can't remember anything, gray hair, but you could write the questions in the chat as they go along. I am sure they will respond and answer to them. This session really is about providing information and pathways for you all to engage and just have fun in mathematics. And again, thanks to everybody for joining us today. Thanks for the panelists in advance for sharing your expertise. And big thanks to Della Kramer for keeping us all on track, moving forward. And with that amazing background logo, right? Doesn't she have like the best background, right? I got to get with the program. Well, when I get electricity back, I'll see if I can get with the program. But other than that, really great to see everybody today. And I'll also try my best to get my LinkedIn in the chat.
So today, we're very honored to have Sherli as our first panelist. Sherli completed her PhD from Clemson University in 2017, where she worked on dynamic health system. Currently, she works as a data analyst with the Office of Institutional Effectiveness at Tuoro University, Nevada. She's an applied mathematician and educator interested in mathematical biology and STEM education. She's also invested in increasing diversity in STEM, particularly for students with disabilities. So yeah, thank you, Sherli.
Well, thank you, Judy, for that. So let me just go ahead and share my presentation. Thank you so much again for the invitation to be part of this great panel. And so let's get to it. Before we start, my preferred pronouns are she and her. And I've put my website, my email, as well as my Twitter handle in here. I should have put my LinkedIn, but I will remember to do that after I am done talking. So a little bit before I get into the kind of research that I do and my job responsibilities here at Tuoro, Nevada, I'd like to talk a little bit about my journey. So I was born in the United Arab Emirates. I did my high schooling in Bahrain and UAE. I moved to India to do my bachelor's and master's in math and another bachelor's in math education before I moved to the US for my PhD. I did my PhD in applied math in South Carolina, did my postdoctoral fellowship in Connecticut, and I now reside in Nevada. A little bit about my other identities. I am a Malayali Indian immigrant and a wheelchair user. I speak English, Malayalam, Hindi, and I'm learning Korean. Okay, so how do I define myself as a mathematician? As Judy said, I am an applied mathematician. I love using biological and educational data in my research projects, and the softwares that I love to use are RStudio, MATLAB, and Kupasi. Due to my multiple identities as a woman, as an immigrant, and a wheelchair user, I am committed to increasing diversity and equity in STEM through my research and mentoring. I'm also the co-founder of CERES, which is the Center for Education and Research for Equity in STEM. Okay, so let's talk a little bit about the kind of research that I do. So during my PhD, I did a dissertation titled Chaos to Permanence Through Control Theory. So a bunch of different things going on there. What I did was I looked at chaotic predator-prey models, and I used a form of control to bring them into a state of permanence. And what I mean by permanence is that the species are at a safe level from extinction. And with this dissertation, I had 2 publications and 1 in progress with a student. During my postdoctoral fellowship, there were 3 projects that I was involved in. The first was agent-based modeling of multi-species biofilms. And what I mean by biofilms, they are an expression of a microbial community. And they're usually found in the mouth as well as on medical implants. And I had 4 papers from this particular project and 2 with students. Another project that I was involved in was looking at fMRI data and trying to use Boolean networks to fit that data. And the last project was spoke more to my identity as a wheelchair user. It was about looking at access for students with disabilities to STEM. And we did present a paper about that, and one is in progress. Okay, so coming to my current position at Tuoro University, Nevada. Before I talk about my position, a little bit about our university. It is the largest medical university in Nevada. We have osteopathic students. We have nursing, OT, PT, physician assistants, as well as an education department. So the kind of research that I do in Tuoro would go into two buckets. One is data analysis, and the other is evidence synthesis projects. And what I mean by evidence synthesis is systematic or scoping reviews. So the image on the far left is that of a forest plot. And this is an image from a paper that has been accepted for publication, and it's about rapid antigen tests used for COVID and the effectiveness of these tests. And this forest plot, what it does is it kind of shows you where the papers lie with respect to a pooled value. And then the image in the middle is a screenshot of a poster that my student had actually presented, and it is about the investigation of chaos theory in a three-dimensional cancer model. And we used Scopasi to investigate this model. The image on the far right is actually a screenshot of a protocol paper, and it is of a scoping review paper, actually. And it looked at diversity-based approaches in American universities to increase the recruitment and retention of biomedical sciences research faculty. This is a protocol paper. So what it means is that we've just told everybody, hey, this is what we're going to do. This is our project. This is what we're going to be looking at. This is our research question. And then the scoping review is underway. Okay, some more details about what I do here is that I lead student teams of size of at least 4 for systematic and scoping review projects. So I have bi-weekly meetings with them. I help them with different steps of the projects. And then I also help perform meta-analysis for these manuscripts. Another duty here is that I provide descriptive and inferential data analysis for professors from the various departments. So some of them may have data analysis projects with existing data sets. Some of them may be retrospective studies, as in they will collect the data from clinics and ask me to analyze them according to the hypothesis they've presented. And then some of them may be survey projects where they will be giving surveys to the students and they need me to analyze the survey. I've also served as an adjunct lecturer for the Quantitative Methods course for the School of Education. I've also given some presentations about introductory data analysis for the schools of nursing, physician assistants, and occupational therapy. I'm also the point person on student-led research projects. So what I do is I match the students with specific research or residency interests with professors who are doing research in the same area. And I also help, and I follow up with the students, and then I also lead student teams. So I'd like to end with what is my research philosophy? So as an applied mathematician, I've realized how interdisciplinary research helps show the applications of math. And my mentoring experiences have reinforced my goal to provide an enriching research experience in math. So the kind of stuff that I do is I use mathematical tools in multiple disciplines. I do experimental as well as longitudinal data analysis, and I love doing student-led projects.
Thank you. Okay. The next speaker that we have is Melissa. Melissa obtained her Bachelor of Science in Pure Mathematics from Morgan State University in 2009. And then she went on to obtain her PhD in applied mathematics from North Carolina State University in 2015. Currently, she's a lead data scientist at ADP, focused on planning projects and building data science models to help improve business decisions. Additionally, she volunteered as the head of education for Atleticus, which is an Atlanta-based nonprofit organization focused on creating a community of individuals empowered to pursue work in the data analytic field, providing new pathway to economic opportunity by offering a data analytic training and certificate program. So I'll let you take it away, Melissa.
Yeah. Thank you. Thank you so much for the invitation. And I'm really happy to be here and to be able to share my experience with the students and everyone here. So let me go ahead and share my screen. So this is my presentation. So I call my presentation Answering Business Question with Words, another approach to storytelling, because I see myself really as a storyteller. I am currently a lead data scientist at ADP, and I have my LinkedIn here, but of course, I will share this presentation at the end for anyone who's interested. So let's continue. My agenda is pretty straightforward. I'm going to give you a little bit about my background, why I love NLP so much. I'm going to talk about one of my NLP projects and then tips and tricks for aspiring data scientists. So pretty much when I came to this country, I'm originally from Cameroon. Actually, I wanted to be an engineer, but when I took engineering classes, I was bored to death. I was sleeping. So I was like, whoops, this is not for me. So I decided to switch my major and I became a mathematician. Why did I become a mathematician? Because I still wanted to be able to solve problems, but I couldn't do it with engineering. And I thought I would be able to do it definitely with math. So I went ahead and I decided to get my PhD in applied mathematics. When I discovered data science really is after I graduated, I realized data science existed. And I was like, wow, so I can solve problems with data. Okay, this is the field I should go on. So when I went to teach at Morehouse College, I was doing most of my research with students that was data science related. In order for me to learn more about data science, I went to a workshop that was at Brown University through iCERM. There I learned that there was so much that I needed to know. I could not do it on my own. So I took a boot camp to be able to learn as much as I could learn, but that still wasn't enough for me. So the next step for me was to transition into the industry. So I first got my position at Warner Media. Then I'm currently working at ADP as a lead data scientist. But while I made this transition, I understood that it is in order for me to succeed in the world of corporate world from someone coming from academia, it was very important that I build a very strong and important network for myself. That's one of the reasons why I joined Athletics. Athletics is an organization in Atlanta that's there to help people from underrepresented group. And I like the board members. They all had very high position, data science positions. So I thought, oh, wow, this is a good place for me to start and go there. So why Love Sight First Sight NLP learned? As you see, I'm a storyteller. So pretty much when you think about data science, you think about the two things that you have to do. Supervised learning problem. You want to be able to predict a house. You want to be able to classify if someone has a good score or a bad score. And then you think about unsupervised learning problem. So unsupervised learning problem, you're thinking about clustering. So you have a data set, you have customers, you want to be able to create segments so you can send them targeted advertisement. And then you get into the world of natural language processing, NLP, that I've been talking about. So this is exactly where I reside, right? When I realized that NLP existed, I was like, wow, okay, since there are words in the data, I'm just going to work on NLP project. So that from that point on, every time I just say, I just want to work on NLP's a project. I don't care about anything else. I can work on those projects, which I've had the chance to do throughout my career so far, but I prefer NLP project. So one of my NLP project, one of the ones that's really fascinating to me right now is how to build a lexicon. So pretty much here, the business goal is that you want to be able to create a transformation layer between the customer speak and the ADP speak, right? So you are, let's say, we have conversation between agent and client, and those conversations can happen throughout the phone or on the chat. When a customer says something, we want to be able to very quickly understand what they're talking about and quickly recommend the article that's going to give them the answer to that problem. So in order for us to be able to do that, we have article content, conversation transcript. And what I'm going to be more focusing right now on is the word embeddings, word2vec, fine-tune word2vec. So those are the things that we talk about. So how do you build this lexicon? So the first thing that you have to be able to understand is that what are the core terms of these lexicons? You have acronym, engram, synonyms, antonym. You have to be able to categorize those terms, right? You categorize the terms based on the context, based on the definition. Then after that, what you're gonna have to do is extract lexical information. So we have different methodology in data science that we use for that, part of speech tagging, synthetic dependency parsing, name entity recognition. You also have to extract semantic information. So in this sense here, what you're doing is that you're trying to transform all the words that you have into matrices where all of the vectors in this matrix mean something. So you can do it using multiple different methodology, TF-IDF, bag of words, word2vec, glove, BERT, which is a transformer models. So really, when you have a word2vec, what you're doing here is that you are doing continuous bag of work. So a word2vec, basically, you want to be able to generate the probabilistic nature of your embedding space so that you can understand what's going on. So with the CBAL, which is continuous bag of work, what you're trying to do is actually predict the context, right? And the skipgram is that you want to predict what's going to happen to the surrounding words of the particular given word. So those things are very important for us when we are talking about word embeddings. So what exactly is the word embeddings, right? So pretty much it is a technique that we use, right, to convert words or text into their numerical representations, which are basically vectors. The second thing that we want to know here is how do we use them, right? I actually talked about it a little bit earlier. We have to figure out the relationship between this word. When we find the core terms and all of those things, we have to find the syntactic, the semantic, and the contextual, right? Because when you're thinking about a vector, right, and the vector representation of check on status and the vector representation of request paycheck, right? You see check is on those two words, but are they synonym? No, because check in one part is actually a verb, and another one is a word, right? So that's why you have this part of speech tagging, this dependency parsing, and all of those different things that we have to do. So why can't we just keep them as word? We cannot, because we have to be able to transform it into numerical data. So that's why we have to do these vectors. So here in this picture, I kind of show you a little bit of what happens after. When you create this embedding, you are able to basically understand if I want to predict this word, the probability, you know, the embedding helps you to get those probability. And what we understand with embeddings is that when you create your embedding space, right, the words that surround each other, you will probably call them synonyms, right? So one thing that we have to understand is that when our customers say certain things, right, and the agent will reply it a certain way, the way that the customer is saying it is actually not the way that the agent is saying it. But creating the embedding will be able to say, oh, usually when the agent says this, the customer has said that. So maybe when the customer says this word over here, like they will say, oh, I want to do my savers account. I don't know what to do. Actually, what they want is a retirement account, right? But they don't know how to say it. But because we have created the embeddings, we are able to say, wow, this over here, it actually means that. So those are the different ways that we use embeddings. So that's the, you know, I'm pretty much in the lexicon word right now. So I'm like I said, I'm like Alice in Wonderland, Melissa in LLP land. I'm just having fun every day. So of course, my job is not only doing word embedding. I'm a lead data scientist. So I think that, I'm going to talk about my job here more as opportunities for growth. Because I feel like when you go from academia to the corporate world, it's kind of like totally different. But so I had to learn how to work on multiple problems at a time, have multi-ownership of my code. It's not my code. Somebody can always come on my Databricks notebook and do whatever they want in there. I have always very tight schedules and deliverable. I also have to answer to stakeholders. I have meetings with them and try to say, this is why it's working, this is why it's not working. Most of my work actually right now is mostly giving guidance to junior data scientists to help them succeed on their project, to help us succeed as a team. You prepare the timeline, you create these different things, and you also think about approaches. What exactly is the approach that we can take to solve this problem? Remember 2 years ago, still on this lexicon work, and we were working, I told my manager, I think the only way to go is an ontology. And right now we are working on knowledge graph, building ontologies, building traversal models. So it's pretty fun. So next, what am I going to talk about? How to get in the door. So I'm going to go very fast here because I don't want to take too much of the time. And you have to build your portfolio. You have to have projects. You have to basically know how to talk about your project very well. You also have to be able to have a social media presence. What do we mean by that? You have to have GitHub account. You have to have a Kaggle account. LinkedIn is very important. You have to have a Medium account. And sometimes if you want to go really and showcase yourself, you know what, create a website to showcase your work, showcase your past things that you have done to build your portfolio. Of course, you go on interview, you talk to different people, because if you want to succeed in this career, which is what I have learned myself, you have to be able to know different people who have different skill set, so that whenever you get stuck somewhere, you are able to go to them and say, you know what, this is what I need. Can you help me? Or do you know someone who can help me? So you can do that by interviewing people and doing different things of the sort. So how did I make my career go well, I guess, in a sense? Of course, I volunteered. Athletics, I started, I was just participating on custom project because I was new to the world of data and I wanted to do as much as possible. But when they realized that I love teaching, they made me the head of the education program, which is a program where we help other people learn how to use data skills to get a job or to maybe help understand their data that they have. Of course, I have many opportunities now. So I was able to get to speak, have a speaker at many different conferences, be a workshop facilitator. I also teach a 1-credit NLP course at my alma mater every fall semester. I enjoy it. My students always give me very great capstone project at the end. I always just want to cry like, oh, I miss my world. I miss being a teacher. And of course, because I love to teach and give people advice, I got to career coach others who are in their transition to become data scientists. And of course, here are many organizations that you can join and learn a lot of different things about data science and how to succeed in this career. And I think that another thing that made me really, really succeed finding accountability partner. So people who are going to be able to help you stay on a timeline. If you're saying, I need to do this in 5 days or something like that, this person is going to be there to help you do that. You have to find mentors. People are going to be giving you advice, people who are going to be identify your blind spots and things of the sort, and also help you celebrate your small success. How do you find this person? It could be your mentor. It could be a career coach. It could be a mastermind group. I think a mastermind group is very good because it's probably a group of people where you are peers, you are on the same level or maybe above or below, who knows. But you come together and you give each other advice. I think that has truly helped me so much. My mastermind group is still going. We all used to work at Warner Media back in August 2019, and we don't work there anymore, but we still meet every third Wednesday of the month. So it's pretty good. Of course, if you want to hear more of me, I have other talks. They are all on YouTube, and one of them is at the AUC Data Science Initiative. So thank you very much. That's all I have. Thank you. And so importantly, but I'm pretty much done. Thank you so much.
Thank you. Okay. Thank you again. We are honored and happy to have Dipanwita as our next speaker. She completed her PhD in applied mathematics in 2018 from University of Houston before transitioning to industry and solving real-world business challenges at scale. Currently, Dipanwita is an applied researcher at eBay, where she drives the ads business. She builds impactful models for advertising strategies. In the past, she also had experience at Cubic and G as a data scientist. So, welcome and thank you.
Thank you. Let me share my screen. So yeah, my name is Dipanwita, and today, I'm going to talk about my journey from PhD to an applied researcher at eBay, and the path from transitioning from academia to industry. So a little about me. Let's see. So yeah, a little about me. I completed my PhD in applied maths from University of Houston in 2018. Prior to that, I'm sorry, I didn't put that here, but prior to that, I got a master's in applied maths from India and a bachelor's in mathematics from India. And even while doing my PhD, I got another master's in financial math. This was from 2013 to 2015. And then my PhD was more on stochastic models. So I was working on a particular model, the Heston volatility model. And my work was basically to do maximum likelihood estimation of the parameters of the model. And one of the application project for this was to predict the volatility of stock prices. So I can talk more about this if you're interested. I will keep this academic part to a minimum, and I will talk a little about my industry experience. So I started working at Cubic just right after my PhD. Cubic is a transportation company. So in San Francisco, they have NextBus. And one of the main jobs that they were doing was trying to predict the arrival time of NextBus. It's basically Uber for buses. And then after that, I worked in General Electric. So General Electric is mostly the energy market. So some of my works involved, predicting prices for our customers. So when there are electricity grids and our customers, which are different electricity providers, if someone lives in Texas, they would know about ERCOT. They have to buy electricity in advance, and we had to predict prices for those. I did some additional work where, when you have a electricity grid running, you also have to see how the electricity is being generated, how, if there is any anomaly in the data. So a lot of anomaly detection work to make sure that if there is any maintenance that is upcoming. And then finally, I right now work at eBay. I have worked in eBay for almost 3 years now. I have worked in various parts of eBay, but mostly I have worked in the ads business and for the various sub-teams. And most of my work at eBay ads involves working with NLP, where we do ads targeting, where I'll talk a little bit more about this in a separate slide, where you have some sellers and we have our buyers, and our main job is to match the seller with the buyer while we make profit for ourselves as well as make profit for the seller, and at the same time show the buyer the right ads. These are some of the projects that I've worked on. So in Cubic, we mostly implemented ML models. So we were working with tree-based model, and we are trying to predict the real-time bus arrival information for NextBus. I have myself ridden in NextBus because I live in California, and it's pretty accurate, and the accuracy gets better. So we have different levels of accuracy going from 30 minutes to 10 minutes to 5 minutes. As you get closer to the arrival time, it gets better and better. And then I did some more work where we were trying to find congestions, where we were trying to predict if there is any congestion in the road. We used Google Map data and then some additional information to kind of figure out if there is a cluster in the road. Is it due to traffic, or is it due to accidents, or some other congestion? This is mostly based on historical data where we would see if the congestion is at a point for a multiple number of times, then we say, okay, this is supposed to be a traffic situation. Otherwise, if this is a one-off incident, then this is supposed to be an accident or some other, something else happened, like there's a rally or something else going on. So all of those involved a lot of ML models. Then I worked at GE. One of the prominent work over there was predicting the day-ahead prices. Like I mentioned before, GE is a company which gives services to more smaller energy companies like ERCOT, and then there's a lot of other electric companies which actually supplies energy to your houses. And they have to get energy from a grid. So they have to buy energy ahead of time, and they have to buy it in such a way so that they have the least wastage, and all the energy they bought, they can put it out to their customers without wasting it, or buying more or buying low. And also to buy it, you have to do a bidding. So you want to make sure what is the optimal bid to buy the electricity, and the bid is supposed to be 1 day ahead. So that's hence the name day ahead prices. And we basically tried to build a model which was trying to bid on our customers' behalf so that they can acquire the electricity needed for their grid. And finally, I work now in eBay ads. I am in the targeting team in eBay. So we try to match sellers' query or sellers' items to the buyer intent. I have a separate presentation for this, just to give you an overview of what I do. Particularly for eBay or for any e-commerce site for that matter, when a buyer assigns a query, it needs to get some item. Because I'm in ads, we have sellers. Sellers set up their own campaigns. So eBay don't sell any item of their own. So sellers try to set up their own campaigns with some items and some keywords. They're all text data over here. So these are very varied. In eBay, unfortunately, we have sellers where they sell iPhone with candy, and they are all the same item, and then all get assigned a generic set of keywords which are associated with items. But because they're like a whole set on the items, seller puts, someone would not know whether this whole campaign connects only item or only candy. So based on the keyword, we first have to identify which item matches to which keyword. And then we have to figure out what buyer query matches to which keyword that results in item which is most relevant to the buyer query. For example, someone searching for crimson or crimson sneaker should match to red shoes or red Air Jordans. This is again an NLP problem. So we use a lot of embedding-based model like BERT, and then mostly we use BERT and then FastText for faster iterations. And then what we do is not just do a simple similarity or semantic similarity matching. We have to solve other problems, right? For example, if there are multiple sellers, which set of sellers is going to fetch me the most money? Because the more item I show with the buyer is interested in, the more money I get. Ads have various type of programs like cost per click and cost per item, cost per sale. So for us, we have to make sure we show items which are most relevant to the buyer query so that the buyer clicks on it and we get money when the buyer clicks on it. At the same time, we have to make sure the seller is getting a good return of investment, because if someone clicks on an item, seller has to pay us the money. But at the same time, the seller is trying to sell their item. So we have to make sure the item is relevant to the buyer query. So it's a very broad overview of the business part of how things look like. And the modeling is basically an optimization problem of selecting the best set of sellers, which will give you items resulting in the maximum click for the buyer, as well as maximizing the return on investment for the seller. Now I want to talk about my motivation of transition. So mostly when we work on PhD, we work with a very small set of data sets. And from my experience in the school that I went to, I just took one course in deep learning, and I landed my first internship in Halliburton before this industry experience. And that's the first time I knew what gradient boosted trees were. I had no idea about, ML or anything related to clustering before I joined my internship. So when I did that internship, I realized, how much you can impact or how much you can apply your everyday, like basic things like distributions and regressions and whatever you're learning in real world. And practical implementation of what you learn it's really good to know that you're actually affecting the lives of people in a daily basis. Like in eBay, you're putting out model, you're showing things, you're trying to connect buyers to your sellers. At the end of the day, it has a big real world impact. You're also making money for your company. And, you also have a very structured career growth, I feel. Like right now, I work as an applied researcher. There are various grades to applied researchers. So my grade is that of a senior applied researcher. I have 2 people reporting to me. And, I lead multiple projects. And we have to talk with external teams. So you have a very broad scope of influence on everyone. And you can decide, how you want to shape the project. You have to deal with timelines and you have to talk to stakeholders. And it's a lot of a learning curve. And the final consideration is obviously financial consideration. Salaries are very competitive in the industry. So that's one of the other reasons why I was motivated to move to the industry. I want to outline some of the challenges that I faced when I went to the industry. With very little to less background in machine learning, it was quite a challenge for me. So, like I said, I didn't do a lot of courses in ML while I was in school. So I needed to go through like a lot of material. When I was very close to graduating, I started doing algorithm and data structure because I don't come from a computer science background. And that is one of the main things that you need to do for the interviews, at least interviews that I went for. eBay had 8 rounds of interviews before I joined the company. Working with large-scale system. Today, when we work at school, we work with GB of data. When you go to industry, you're working with petabytes of data. So you have to know how to scale your model, how to, make sure that it works at a real time. When a query comes in at eBay, everything has to happen in 5 to 10 milliseconds. It's very difficult to train a very heavy model and not know how to deal with it at runtime because you have to give your solution in 5 to 10 milliseconds. So scalability is something which we don't learn while we are in school. So that's something I had to learn. Of course, adjusting to different work environments, working with workflow and system design, computer science background. Like I said, I don't come from it. So we have to learn a lot about design and scaling, how to deal with Airflow and then Kafka queues, Docker, how to run, build your own libraries. So these are something which I have learned throughout my career in the industry, like learning new tools and technologies. And then the last thing is thinking beyond building models. So, ML is just a very small part of your project in the industry. The main idea is to obtain a business objective. So you should know about the downstream task of A/B testing, how to know that whatever you're building, is this even working? Is this even, deploying, when you deploy a model, is this even scaling at real time? So those are some of my challenges that I faced. And yeah, I mean, I can share a whole glossary of items on what are good materials to go through, prepare for the industry. So that's all from me. Thank you.
Thank you. Okay, just a kind reminder. I know there's a lot of questions coming in for the chat, and we recorded it, but please hold on to it till the very end so we wouldn't lose any. Okay, our last speaker is Neha. Neha holds a master's degree in applied mathematics from Iowa State and a dual bachelor and master degree in physics from the Indian Institute of Science, Education and Research, Pune. Currently, she works as a tech lead at Walmart and is focused on building generative AI applications. Her past working experience included working in Capital One's Capital One, and Snagajob and Optimus. At Capital One, Neha focused on developing a risk model that helps the business minimize losses by optimizing engagement with customers after they have charged off their credit cards. At Snagajob and Optimus, she researched and implemented a wide range of machine learning solutions from natural language processing models to US election forecasting. Overall, Neha works along and across AI and machine learning, data science, business, product, and software engineering teams. She is passionate about applying well-managed software engineering principles to data science. So yeah, thank you.
Hi, everyone. Before I start my presentation, I hope you took lots of notes from everybody. So I'm going to try to not repeat things because it's so hard to follow from three amazing speakers. So I'm going to go slow. I'm going to focus on two things. I'm going to tell you a story along the way. I'm going to focus on what they had given us four things. One of them was going to be my academic journey, like all of us have done. And hopefully that gives you a good idea of what different journeys look like and what I learned along the way. And lastly, my list of things is not as comprehensive as others, but 3 points that you can remember when you're applying for any of your jobs. Firstly, thanks for coming here. My journey in data science also started with coming for a seminar just a few years ago. Here I am from 2017. I went for boot camp and I'm here to share my story, what I've learned along the way. All I'm going to say is ask a lot of questions. This is a great opportunity for all of you. I know you're already adding more, but don't leave without asking a question. So getting started, one sec. Okay, so my career journey has been I'm going to start from my undergrad to what I do right now. And I feel like the slide is going to get really busy as I go through different slides. So I want you to focus on what is written at the top and the bottom. The top is going to tell you what I did, like BS in mathematics. I explored physics, math, chemistry, computation, and biology. I deep dived in physics and math. I did a lot of research projects. And at the bottom, I'm going to write what I learned in that skill set that helps me today. So that's the way to read the slide, but we will go along for the ride. At a higher level overview, BS and MS in math. I've also MS in physics. I was a grad student in applied mathematics in Iowa State. I came here for a PhD, but I'm going to talk more about personal decisions of moving away from a PhD to a master's, and I feel okay with that choice. Then I was a data scientist at a small startup, a slightly larger startup. So 12 people, 300 people, 50,000 people, and then at Walmart, 1 million. So I have worked across many different sizes and different kinds of things. So politics, online marketplace, financial services, and retail. So I'm going to take you along. So when I started, I went to a very interesting school. It was called Indian Institute of Science Education and Research, and this was like a experimental school in India. They wanted to focus on basic sciences, so they offered us and they asked us, make your own undergrad. And I'd always liked physics and math, mostly because of two reasons. They follow me throughout my career. I am very lazy. I don't want to remember a lot of things, but I know I can derive things. So I chose physics and math instead of chemistry or biology, because then you have to remember fewer things, you can do more proofs, and it's a lot of fun. And that is going to stay constant as we go on. And the key things that I did when I was an undergrad, we were forced to take all the things like physics, chemistry, biology, computation. And it really helped me in my critical thinking. It really helped me build basic sciences foundations, which you're all getting right now, and a lot of my thinking frameworks, and I learned how to teach myself. I cannot emphasize this enough. I learned a lot about how to teach myself. And the second thing that I did a lot during my undergrad was I worked in many research internships from the very first year of my undergraduate degree. I've worked in biology. I've been on a field and collected moths. I have worked on, I was really into like game theory in my second year. So I worked on random networks and how things move around on a network, which now I think of the pandemic and I was like, that was pretty cool. I know exactly how that works. And then I worked on quantum chemistry. And I used all the skills like physics skills to figure out how molecules vibrate and how you can like don't have to do experiments, and used Fortran and Python and all of those things. And then I worked in statistical physics. But all along, the thing that I loved the most was how can I use math to solve a real world phenomena. Whether I've moved across, I've done the same thing. I've tried to figure out how the world works using math. And that's why it was my first love is physics. And then turned out it's called more like applied math if you are trying to go for grad school. So I was like, fine, I'm going to go to an applied math program. So when I came to grad school, I am from a very small city, but a very vibrant city in India. I came to Iowa and I didn't know what I was doing really, but the applied math program was a lot of fun. I got to go way deeper in applied math. And I didn't know at this point what I wanted to do. I still always wanted to do applied stuff. So I took stats, I took a lot of linear algebra, I did a lot of proving, continued to do proofs. But I realized when I was there that, pure math is not enough for me. I want to be like doing more data. I want to like I was doing a lot more of biological systems or like other stuff. I want to do a lot more of that. And so what I did, a key thing, and I want to pay, because you're in this phase, most likely I want you to pay attention, is I did two things. In my first year, I went for an industrial math workshop where I worked with people from geology, I worked with people from math, statistics on a problem that is relevant. So it was 10 days. You learn what the problem is, you learn how to work with people, you produce a model, you write a report, and you present all of that in 10 days. And it was amazing. I got to see what you can do with EPA, what you can do with the national lab. And I was like, this is exactly what I want to do. So next year, I actually applied for another thing, which was called IMA. It's a boot camp meant for math students who want to go into industry. And this was 6 weeks long, not just 10. And they went through a lot of things. They went through Python, which is a coding language. They went through basics machine learning and stats and like optimization. And we worked with applied math folks who are in industry. And that really helped bridge the gap of what it really means to go from like grad school to there. And I already had built a portfolio of projects, which is, as Melissa said, you need to have projects, you need to build a portfolio. So I did all of that, and I learned how to communicate because I had taught in grad school. All of those skills are really important when you are moving somewhere else. So we have done undergrad, we know physics, we know math, we have done some projects. Now it was time to get a real job, right? I decided I wanted to move from my PhD to getting a job, and I was like, I'm gonna graduate with a master's. And here is like my identity as an immigrant comes into picture. I am from India, so I had to, like, you cannot be on unemployment more than 60 days or 90 days. So I wanted to find a job really quick. So I was all about quality over quantity. So when I was in the boot camp, basically I made really good connections with the 2 or 3 mathematicians who were on as leaders in supervising the projects, and one of them clicked and they helped me get a referral for the next job. So when you're actually applying for jobs, remember referrals are big. Find people in your network who are there in those jobs, who look like you, who are from math, and like anybody on this call really. And she helped me get my first referral in the field that is completely different. So my first job was in politics, and the only thing that I focused in on here, again, is going back to the fundamentals. I'm from math, I wanted to do data science. So I wanted to find a company which does it, their bread and butter is data science. So I worked for this company called Optimus. They do survey design, polling, predictive modeling. And they wanted to build a lot of models for saying who is a swing voter in the beginning. But they also predicted who is going to eat a pizza, who is going to do something else, who is pro-choice, all of those things. But as an immigrant, I cannot actually advise anybody in the US on how they should conduct their campaign. So I was actually doing a much cooler project, which is let me predict elections. So imagine coming from math, pure sciences, to this new job. It's 6 months. I know nothing about US politics. Like, who knew? I'm from India, why should I know? But clearly one should know. uh, so I basically learned everything. I used my stats. Survey design is nothing but stats. I used my core skill sets to build models. I learned like gradient boosting machines and random forest and jags and like whatever you want. I'm teaching myself all of these things. I'm also learning, doing a lot of data analysis and using really a lot of hypothesis testing based concepts that I've learned in school to figure out, okay, what is missing? How do I make a new model? How do I improve this? And I really embraced something that is very important. In industry, you figure it out. You're not an expert, you figure it out along the way. And I think that was something very hard for me to learn, that you don't need perfect, you need something that works first, and then you iterate very fast. So there I predicted elections. I can definitely send you a link, you can go and see. We built a website. I learned how to communicate, explain what the model is doing. And then I'm over time, but I'm gonna go. Is it okay if I'm over time? Okay. Then I realized that, okay, something that I'm missing, I can do really good data science and I can use all of these principles. But again, like Dipanwita was saying, you need to know how to scale your systems, how to work with big systems. You cannot be in a Jupyter notebook all the time. And I think one of the things I want to mention, you don't have to know all the things. You can learn along the way. The industry is actually very appreciative of what you can learn along the way. So focus on things that are your strengths. And so what I did, once I had realized I want to work with larger systems, I was like, I need to go in an engineering org. I want to know how to build really good stuff, really write really good code. So I went into and this was also partly influenced by I needed an H-1B, and these people were ready to sponsor my H-1B first instead of Capital One. So Capital One was like, go get your H-1B and then come here. And also Snag a Job was a great company. I learned a lot of things. I learned a lot about different industries. So this was like an online marketplace. Think about LinkedIn, but for gig workers. They're dishwashers or truck drivers. So again, a new business altogether. How do you understand something so new so quickly? And like having been in many different applications before has trained me how to learn a new system now. So basically, I learned natural language processing. I figured out how to do data analysis and understand things here, word embeddings like Melissa was mentioning, and really learned how to build NLP models to predict stuff and upped my engineering game. And then I went, after a while, I went to Capital One. And I think this is the place where I learned like a lot. I learned, again, this is Capital One. If anybody's looking for jobs, they're not paying me to say this, but I highly recommend going to Capital One. Capital One is a great mature place to do data science. Their whole company depends on them predicting really well who can make a payment or predicting fraud, a lot of those things. I learned a lot about, I think this is where I came back to academic rigor. You have to think really hard what your model is doing. You have to explain everything really well. You have to write a lot. I thought writing papers was out of the window, but not anymore. I was back to technical writing. I was back to talking to business. And I think this is where I also learned storytelling. Like, it is so important. Like Melissa said, you have to tell a story. It doesn't matter if you can't tell a story. And I learned a lot about like non-technical skills and how to show up, how to build a network, how to get work done with other people. And all of these will come to you later. But remember that there's a lot of different things you learn at different stages of your career. And I started leading teams. And now I'm in Walmart. I work here. I wanted to work with larger systems. So I've worked with a smaller system. I know how to produce really good things. I know how to write. I know how to communicate. I want to go bigger. So now I work at Walmart. And I am again in a completely new field. Again, I'm back to NLP. I know my basics because I've done that in 2019, but taken a gap in between. And I'm back in an engineering org. I'm a tech lead. I mentor students. fellow teammates. And along the way, I have always been involved in mentoring, being mentored. At every stage, I've had a lot of mentors. And that is probably one of the great reasons I'm successful. And then that is kind of my career journey and what I have learned. So I feel like you have all the foundations when you're a undergrad student as maths person to really succeed in data science. And if I were to do a very rough draft of what I would tell my younger self, is I would ask a lot of questions. When I move from one field to other, the thing that helps me the most is I ask a lot of questions. I go back to my fundamentals. If you're taking courses, take many courses as you can. Something I did not know was helping me, but really helped me is being multidisciplinary. If you're only in math, I highly recommend going to colloquia, listening to talks that are different from your field, which are applications of math. So you start hearing things that are adjacent to math. And this was like from my undergrad is what I've been doing. And I think a lot of time when you're doing research, you have to be perfect, or like you have to you spend a lot of time, but industry is different. Industries, you get on the problem very quickly and you start, just do it. Like just do it, make a portfolio, make a website, go or do a tutorial. If you can't figure out a project by yourself, first copy somebody else's, and then from there start to get ideas and be curious, and then ask a question and then move forward. Find mentors, and most importantly, sponsors. If you don't know what's the difference between a mentor and sponsor, I highly recommend looking this up. Sponsors really help you get the job. They advocate for you externally. They advocate for you in your job. They bring opportunities for you. And I've had a lot of them. And at every stage of my career, especially as a woman, you need somebody to talk about you at different places. And lastly, I think something that I do every day, and sometimes I have to remind myself, is math has helped me with my problem solving and thinking from first principles. I use that every day. I read a lot, I take a lot of courses, I self-teach. All of that is from undergrad and grad school. And I think this I've learned over time, that I will never know everything, and that's totally fine. You can learn, and that's great. And often we try to fill our gaps. I tell myself to play by my strengths. And I know I went really fast, but I'm gonna stop now. And hopefully you have questions.
Thank you, Neha. Okay, before we transition to, as we transition to the Q&A session, I'm gonna hand the moderator to Jasmine for announcement.
Okay. Thank you, Judy. And thank you again to all our speakers. Please join me in giving them like a virtual applause using a reaction, maybe. It was really, truly interesting to hear about all the diverse work that's being done under this umbrella of data science. I did not know that there's like so much work from politics to ads to academia. It covers it all. And it was very inspiring to hear about all the challenges that you faced and how you overcame them. And I think it must have given everyone a lot of insights into where they can begin their journey. I already see that there are a lot of questions in the chat and the Q&A. So we'll get to them in just 1 second. I'll take less than 30 seconds to tell you a bit about our next seminar in case you're interested in joining it. Okay, our next seminar is going to be on 13th September, if you want to mark the date, and it's going to be about mathematical careers in the intelligence community. And we have a great panel. We have Amanda Carr, who's the STEM technical leader at the National Security Agency, Michelle Kerr, who's an applied research mathematician at the NSA, and Kelly Yancey, who is the research staff member at the Center for Computing Sciences. And they're going to be telling us about their journeys, their career paths, and also about some current mathematical research and how you can apply for positions, including summer internships. So if that's something of interest to you, please be on the lookout for an announcement about this, and it will also be available on our website so that you can register, but it's on September 13th if you want to mark your calendars. Okay, so with that, I'll just get back to our Q&A. Okay, our first question is by Monica, who asks, are there things you wish that you had done differently as an undergraduate? And also, if you have any thoughts on data science undergraduate degrees versus math, statistics, or CS degrees. And I think Melissa and Shirley already had some insights to offer. So Neha and Dipanwita, if you have something to add to that.
Yeah, so I can talk about my experience. I come from a very math background with little to no background in computer science. So when I was interviewing, or when I first started interviewing, um, I think I got asked this question: given a M by N checkered box, how will you go from the left side of the checkered box to the right end of the checkered box? If anyone know anything about computer science, they would know about data structure and dynamic programming problem, but I had no idea what the person was talking about. And it was an interview at Lowe's. And I actually solved this by writing a small m and an n, and then I solved it mathematically. And then he said, okay, but can you code it? And I had no idea what to do or how to code it because that's a different algorithm. So I self-taught myself about data structures and algorithm, which is, I think, at least one round in most companies on most data science interview. I had multiple rounds in eBay, which asked me these kind of questions. So it's, no one told me how to do that or what to prepare for, but that's one of the very fundamental things that's required, at least if you're trying to go in the industry. So I think most of us have heard or not heard, people in the industry might have, about lead code. So go for it. And there are about, I think, 2,000 questions that you can solve. And there are also books like Cracking the Coding Interview, which has very fundamental ideas about what data structures are. And I can guarantee you, in almost 80 to 90% of the company, at least one round would be about data structures. So that's something I would definitely say. Coming from a math background, I had no idea about those things. So that really helped me when I learned about those and helped me prep for interview. But I would say, coming from a math background, it did give me an edge over all the mathematical and ML rounds where a lot of other people might have struggled. So it really, really helped me.
Yeah, I guess I have like a totally different approach. I did take computer science 1 and 2 in undergrad, and then after that, like my professors used to tell me, "Oh, you code like a math major," so it's like, okay. But really, when it comes to the industry, I as long as you know Python, and I believe that Neha mentioned that you can copy, at the beginning you have to kind of copy what other people have done. And then from that point, you kind of start learning. So my thing is actually that I actually take all interviews because I think interviews are like training session. But when it comes to, oh, this is the coding interview, I say, okay, good, I'm good to go. I actually do not take those interviews. Because actually, no, I'm gonna fail. My mind is a mathematical mind, like just trying to code, like this kind computer science people. I tried. Actually, I did hacker around, lead code when I was, transitioning. I did all of those things, but regardless of how much I train myself during the interview, I just freeze. So I just decided this is not my strong suit. I'm just not going to do it. So when those kind of technical interview comes that have this kind of thing, I just already know I'm not going to do well. So I just give up. I'll say good. And it hasn't hurt me at all because I still do my job and I'm doing it very well. I'm very, very good at my job. I know what I'm doing, but I cannot code, like that. I cannot so. That's kind of like my different ways, but definitely you should study. I did study, but it doesn't matter. On the interview, I cannot do it.
Trust me, I failed a lot of interviews. I just got lucky for eBay. I also failed a lot of interviews. It's not easy to life code. I mean, it's not like your problem. It's like a general problem.
I want to emphasize something here. I think both Dipanwita and Melissa has said this. Like, it's like you fail a lot before you succeed at an interview. So you don't be afraid. Like, I feel like the first time I also did an interview, I froze. Like I know what that feels. And for me, that is preparing like a lot. And like, for example, there was one time I was going to have an interview with a big company, and I literally, the coding interview, I have found the best way I learn is by doing. I'm a tactile learner. So what I will do is I will force myself into a situation that I'm about to face in an interview. There's something called pramp.com. I cannot stress this enough. This has single-handedly helped me crack a coding interview. Yes, lead code helps a lot because they give you the questions that will come up, and like a lot of other things, data structures are important, but practice makes perfect. I think that's what I've learned in coding interviews. Practice. Pram.com gives you, like, you can do mock interviews with other people. I've learned a lot by seeing other people code. I've seen how they think. Most of the time you have to express how you're like thinking. And when you get like feedback, you are like, oh, okay, I'm doing right. I can go on. And you get half in. That's totally fine because that's what they're evaluating. And the more you do, the more you learn and you eventually get it. Something that I would have done differently is I would have done a lot more projects. Somebody asked breadth versus depth. I would have chosen something that I am really interested in, and I'm really mean this, something you are curious about. Because the moment you find something that you're curious about, you're going to go deep inside it. Nobody has to force you to do something. And then you can, like, they're interesting questions. Nobody has thought about them as much as you have, which means you have an edge when you go in an interview and they ask you about that, and they're like, oh my god, that person has thought about it so much, I didn't even think, because they're at surface. So I feel like it gives you a real edge in showing that you can use the tools, you can tell a story, and you are really passionate, and passion goes a long way in having somebody hire you.
Thank you. I think this is a good segue since we were talking about coding into another question, which Jennifer asked, which is if we can learn one programming language to start with, what's a good one?
Python, I guess.
Python. Python.
The universal answer.
Okay, so that was quick. So I think another question is, how do you handle ethical issues in data science?
So I can speak to that a little bit. Especially because we deal with a lot of medical data, it's always good. And we have to do the institutional review board training and all of that about the ethical issues of collecting this data, especially if you're looking to collect data about underserved communities. So one thing I've realized in all of my manuscripts and all of my, even when I talk to professors who are collecting this data, is transparency. You have to include the community that you are collecting data about. You have to talk to them. You have to ask them what it is that they need. Is your question even relevant to them? And then also when we are collecting data, when we are analyzing the data, it's good to talk about that. Like you speak about the data set, you speak about the people, and you also say, hey, historically, this is what has been done. This is how we are trying to do this. So transparency really helps when it comes to that kind of data. And especially most of this community, like speaking from the experience of a disabled person, like they are wary of such questions. They are wary of such research. So it really does matter if you talk to them, if they are part of your research, and if they are part of your discussion of even coming about the research topic.
Thank you. Does anyone have anything to add?
I think that with my team mostly work with generative AI and ChatGPT. I think there's also a lot of ethical issues that we have to take into consideration. Like one thing, for instance, I'm part of the summarization project. I'm the lead scientist for that. So we want to summarize your call. And I think that with everything that's out there, ChatGPT does very well with summarization. And one thing that we notice is that when you have the name of the customer or the agent, GPT is taking some liberties with, thinking about the gender of this, of the person on the call. So we were able to come up with ways inside of our prompt to make them gender neutral, because we understand that, when you have people talking to each other, we actually don't know. ChatGPT doesn't know. We don't have the voice call. Those are all transcription. So I think those are very good. And also we are always reading paper, making sure that what we are doing is very good. I think even ChatGPT sometimes, it gives you error because it feels that you are using a word that is not correct. So even OpenAI itself has those things. Like when you talk about terminate an employee, ChatGPT is like, I don't want to continue here, but it's like, that's where you talk about the lexicon, because terminate in the ADP world is not, in the HR world, it's not really ending, it's just ending a contract, right? So those are all things that we really take into consideration, I guess. Yeah, in that sense.
I'm going to move on to the next question because I want to cover as many of them as we can. The next one is, does anyone have experience with spatial data science projects or complex adaptive system analysis? Okay.
Spatial? No, probably not, I guess.
Okay, I'm going to take that as a no for now. Okay, Beatrice asked, in terms of constructing a portfolio, do you think I should focus on breadth or depth? As in, should I keep making projects that focus on the same skill, or should I showcase multiple skills and types of projects?
I guess I can take that question. And so basically, when people come to me and ask me for advice about data science and how they should build your project, I think that you should actually try to go to different talks, and see what area is important to you. I showcase how I looked at the different things, supervised learning, unsupervised learning, and then I learned NLP. And now what I did is I tried to do every kind of NLP project, right? So you have topic classification, topic modeling, entity recognition, and things of the sort. So now when I go on an interview and I talk about myself, I can talk about my project because I love what I'm doing, right? Like one of my project was about predicting when I was building my portfolio, once I heard data NLP existed. So my first project about NLP was, if you had songs, how do you able to predict who is the artist? And while working on that project, I did not know that, for rap songs, for instance, a lot of people, the rappers, they will say their own name in the song. They will say their group name in the song. You have to remove those things because, you don't want to overfit your data, right? And actual project that gave me my job, my first job at Warner Media, was the call was ending. Like my then manager had finished interviewing me, and then he started talking about the election, and I was like, wow, yeah, this reminds me of my project that I did. You know what, it was so interesting to do this topic modeling project because, you know what, I did not understand this. So I had a topic model about the Supreme Court, I had a topic model about this, I had a topic model about that. He was like, and then he was like, oh my God, I wish you were already on my team so I could take you with me to Washington. I was like, yep, I got you. So, being able to talk about things that you love is really what it is. So the passion, it's really what it is. Like, focus on the project, the area that you like, and do different projects in that area. That would be my advice.
Same.
Dipanwita and Shirley, did you have something to add?
No, she actually said everything that we were going to say. So.
Okay. Okay. Thank you, Melissa. Okay. Brittany asks, how important is obtaining a master's, and is it helpful to get started in this field?
I would take that as, I think it is important simply because that's what the job market is looking for. Or, unfortunately, like, I'm not saying that just with your bachelor's, you're not capable. It's just that sometimes that is what they're looking for. But internships do help. Like if you are able to do financially able to do at least an internship or two, experience does help. But I think a master's would be needed. And correct me if I'm wrong, but I think that's what you would be asked to do a master's. Yeah. Or you can go into, or you can go into companies that offer to do your master's for you. But you'd have to be with that company for at least 2 or 3 years.
I think the job market right now, at least from the tech side of things, is very, very difficult. So more degrees you have, the more advantage you have as a fresh grad when you're trying to, that's how your resume will stand out.
Okay. So finally, I'm going to paraphrase 2 questions into one, but I think that they are asking a similar question, which is, how strong of a math background do you need to succeed as a data scientist? Like, do you need to be a math expert to be a data scientist? And if you have any tips for succeeding with that. I think all of the panel does have a background in mathematics, but in case you have any experience with that.
I don't think that's necessary because I have people in my team who have PhD in economics, who have PhD in completely unrelated fields from maths, but they're still working as applied researchers, building models, working on NLPs. So if you can teach yourself along the way and provide what the company is looking for, I don't think there's a lot of people from various backgrounds. It's not a necessity as long as you crack the interview.
Yeah, I think just having foundational knowledge of math, like knowing calculus, knowing stats, knowing linear algebra. I think like when I interviewed for Capital One, they made me read a reinforcement learning paper. I had to present a paper. I had not done. I had it was 2 years after I graduated. I had never done anything related to reinforcement learning. I had 1 week. I took a 1 week off, and I was like, well, turns out I'm gonna present a paper. So I just learned everything that I had to learn and presented a paper on reinforcement learning. So I have found that it is helpful to have a solid foundations. You don't have to have know everything, but you should know enough that you can figure it out. I think that is for yourself, whether you get it through a formal degree, whether you get it by teaching yourself in your off hours, it's up to you. But just I think growing, especially with the field changing so fast, like from 2019 to now, like BERT came in 2019, today it's ChatGPT, like it is very fast the way things evolve. And you have to be just ready for it. And for me, I feel like if there was one course that I would like linear algebra and stats, just take that. Take some calc.
And to add to Neha's point about you have to be willing to learn. And thankfully, social media with all its pitfalls, it does have a lot of resources out there teaching people things that were mostly textbook driven. So, look to YouTube, look to TikTok. There are people out there who are giving their time to teach certain concepts.
Let me just take a moment to thank all our speakers again. And thank you all for joining us on this Friday afternoon or evening, depending on where you are. And I know that at the end of the week, everyone is ready to go, but you spent your time with us. So thank you very much.